Hello and welcome to another video by www.electricalpereview.com. This is Zach Stone, the lead instructor, and the subject of today's video is base changing per unit impedance. So when does the old base equal the new base for our voltages? When do we get to use this shortcut? So let's look at a transmission line and plug in some values to actually get some practice using this. On your screen is a three-phase transmission line represented by this single line diagram here. We've got a three-phase 150 MVA rated generator with an output rating of 13.8 kV and a percent impedance of 5.9%, feeding a step-up transformer three-phase rated for 100 MVA with a 13.8 kV to a 230 kV voltage rating and an impedance of 6.8%. And then we've got a second step-down transformer three-phase rated for 45 MVA with a voltage ratio of 230 kV to 13.8 kV and a percent impedance of 5.4%. So the first thing I'm going to do is I'm going to split this up into voltage zones. And if you're not familiar with this, I suggest taking a look at our per unit article on our main website, www.electricalpereview.com. I'll leave a link in the description below of this video. Okay, it's a really important tool to know how to use. So we've got three voltage zones because of these two transformers. So I'm going to call this first zone, zone number 1 here on the left. Next, we've got zone number 2 here in the center. And last, we've got zone number 3 here to the right. Let's say we want to express the 5.9% per unit impedance or percent impedance of this generator. We want to base change that and express it in the base values of transformer T2. So how do we do that? So first thing we got to do is we got to find what the power and voltage bases in this zone over here, zone 1, what our new bases will be, because that's the zone that our generator is located in. So let's start with zone 3 and work our way all the way to the left. So the power base in every zone and every voltage zone will always be the same. So again, since we're using hypothetically transformer T2's ratings as our base values, our new power base is going to be equal to the power rating of transformer T2. Okay, so that means our new power base in zone 3 is going to be equal to 45 MVA. All right. And we just said your power base in each voltage zone is always going to be the same. All right. Now let's start with the new voltage base in zone 3. Since zone 3 is on the secondary side of transformer T2 and we're using transformer T2's ratings as base, our new voltage base in zone 3 is going to equal the secondary voltage rating of transformer T2. That means our new voltage base in zone 3 is going to be 13.8 kV. All right, for zone 2, notice how zone 2 is on the primary side of transformer T2. And since we're using transformer T2's ratings as base, that means the new base voltage in zone 2 is going to be equal to the primary voltage rating of T2. So our VB new in zone 2 is going to be 230 kV. Now, to find the new base voltage in zone 1, it's going to be a little trickier, but not too bad. So we're not using transformer T1's ratings as base, right? We're only using transformer T2's ratings as the base values of our system. So that means we need to step the voltage rating in zone 2 that we already found out to be 230 kV. We're going to have to step that value through transformer T1 using T1's three-phase voltage ratio. So how do we do that? Well, we can say our voltage base in zone 1, our new base, is going to equal to first 230 kV. That's just this value here. And then we're going to multiply by a fraction, right? By T1's three-phase voltage rating. Now, when we step through T1 from the secondary to the primary, we're going from 230 kV to 13.8 kV, right? That means from right to left, we're actually stepping our voltage down. So to step this 230 kV value down, I need to multiply by the bigger of the two voltage ratings of T1 on the bottom of my fraction, right? On the bottom of this transformer ratio. So the bigger of the two voltage ratings for T1 is 230 kV, that goes on bottom, and the smaller of the two voltage ratings, 13.8 kV, 13.8. And so now all we're doing is we're stepping the 230 kV voltage on this side, our new base on zone 2, through transformer T1 to determine the new base voltage in zone 1. So look at this. Because these equal, right, I've got 230 kV on top times 230 kV on bottom. My new base voltage in zone 1 is going to be 13.8 kV. All right, so we've got for zone 1, zone 2, zone 3, we've got our new power base and our new voltage base in all three. Let's finally go ahead and base change this 5.9% to the base values of transformer T2. All right, I'm going to call this number our Z per unit old. And down here, we want to find our Z per unit new. All right, what do we do? To find Z per unit new, I'm going to multiply Z per unit old times the old base impedance, and then we're going to divide by the new base impedance, right? So all this is our classic base change formula before we start putting in those fractions. So let's expand on this a bit. We've got our old per unit impedance. That's going to be 5.9%, or expressed as a decimal, we can just say 0.059, right? That's Z per unit old, the per unit impedance of that generator. Now let's multiply this by our old base. So anytime you have a percent impedance of a machine, it's always going to be expressed in the base values of the rating of that machine. That means this 5.9% impedance has an old voltage base of 13.8 kV and an old power base of 150 MVA. So let's turn ZB old into VB old squared divided by SB old, right? So our old voltage base squared is going to be 13.8 kV. Again, that's the old voltage base, the rating of the generator, divided by the old power base. That's the power rating of the generator, 150 MVA. Next, let's divide by our new base values. Again, what zone is the generator in? It's in zone 1, so we've got to use the new base values in zone 1. All right, the new voltage base is 13.8 kV. So on the bottom of this fraction, I've got 13.8 kV squared. That's our new voltage base, right? Divided by what's our new power base is 45 MVA. All right, let's clean these two fractions up just like we did before. Here's our old per unit impedance. Here's our old base, our old ZB, 13.8 kV squared divided by 150 MVA. And then next, I'm going to bring our new base, this fraction down here, I'm going to bring this fraction to the top just like we did before, okay? So I've got 45 MVA on top, and I've got 13.8 kV squared on bottom, right? I'm still dividing by my new base. Nothing has changed mathematically. Now, look at this. The new voltage base, 13.8 kV in zone 1, equals the old voltage base, 13.8 kV, right? That's the voltage rating of our generator. So these two terms cancel. All right, let's clean this up one more time before we punch it in our calculator to really bring this point home. So here's our old per unit impedance. And now I've got 45 MVA on top divided by 150 MVA on bottom. Remember, this looks backwards, right? This looks backwards. 45 MVA is our new base. 150 MVA is our old base, but these are just the power bases. Hidden in here are the voltage bases. They've just canceled each other out because they're equal, so it's like multiplying by 1. So it looks backwards, but it's actually the same old base on top of the new base formula that we use for base changing. All right, let's try this in our calculator. For Z per unit new, in my calculator, I've got 0.059 times 45 MVA divided by 150 MVA. I'm just typing this into my TI-36X Pro here, and I get a new per unit impedance for that generator expressed in the base values equal to T2's ratings as 0.0177 per unit. Or, of course, we can express this as a percent impedance by moving our decimal over twice, right? 1.77%. All right, so there you have it. We just base changed our generator percent impedance, 5.9%, using a new base value, right? The ratings of T2 as base. So what's the takeaway on this again? Remember, this over here, when we get to this part, it looks like it's backwards, right? We've got our new base on top of our old base instead of our old base on top of our new base. But these are just our power bases, right? Our 45 MVA over our 150 MVA. Hidden in this shortcut formula is the fact that our old and new voltage bases canceled, right? They're still there, but it's just like multiplying by 1, so it has no effect. How can you tell if you can use this shortcut First of all, if you're not sure, just do it the old way. With a little bit of practice, you can do it pretty quickly. It's going to keep you out of trouble on the PE exam. But if you want to double check to make sure that you can do this, all you have to do is look at the voltage ratings, okay? So for example, what's the voltage? I'm just going to clean this up so it's easier to see. And let's grab red so it stands out. What's the output three-phase voltage rating of our generator here? It's 13.8 kV. What's the primary voltage rating of the first transformer, right? When we follow this 13.8 kV to the first transformer, the primary voltage rating is 13.8 kV. Okay, they match. That's great. Now, what's the secondary voltage rating of T1? It's 230 kV, right? We've got 230 kV on the secondary of T1. Now, we want that to match the primary voltage rating of the next transformer. So we follow that down. And look, the primary voltage rating of transformer T2 is the same, 230 kV, right? In order for your old and new bases to cancel, everything on your three-phase system has to match your primary ratings and your secondary ratings. Otherwise, remember when we calculated our new base voltage in zone 1? If these were any different, right, these, instead of having 230 on top, 230 on bottom, we would have had a slightly different number and they wouldn't have canceled, okay? That means when we carried out the long form of our per unit base change for that impedance, we wouldn't have had a perfect term on top equaling the same term on bottom, right? This wouldn't have canceled, so we wouldn't have been able to use that shortcut. All right, if you want to see other examples, like I said, that per unit article we have is fantastic. I highly recommend it, especially if you've never done voltage zones before. It'll give you plenty of examples on calculating the different bases in each zone, even going further to calculate the base current in each zone, which we didn't do in this video. I will drop a link to that article for extra practice on the bottom of this description. All right, that's it for now. Hope this clears up the confusing subject of base changing per unit impedance. See you next time.